Hello, today we're going to explore a fascinating and useful topic in mathematics, divisibility tests. By the end of this video, you will be able to understand what divisibility tests are, apply them to check if a number is divisible by 7 or 11, and discover some amazing shortcuts for division. So what exactly is a divisibility test? Simply put, it's a quick way to determine if one number can be divided by another without leaving a remainder, and without actually performing the long division. Think of it as a mental shortcut. Instead of doing a full calculation, you can use a simple rule to get the answer much faster. Why are these tests useful? Well, they're not just for math class. They can help you simplify fractions, factor numbers, and even solve real-world problems more efficiently. They're powerful tools for building your number sense. Let's start with a number that often gives people trouble: 7. Today, you will learn a reliable divisibility test for 7. The test for 7 is a bit more involved than for numbers like 2 or 5, but it's very effective. Here's how it works. First, you take the last digit of the number and double it. Second, you subtract this double digit from the rest of the number. If the result is divisible by 7, then the original number is also divisible by 7. If the result is still a large number, you can repeat the process. Let's write that down. Double the last digit and subtract it from the rest of the number. Repeat if necessary. Let's try an example. Is 357 divisible by 7? We'll test the number 357. The last digit is 7. We double it to get 14. So 7 doubled is 14. Now we take the rest of the number, which is 35, and subtract 14 from it. 35 minus 14 equals 21. Is 21 divisible by 7? Yes, it is. 21 divided by 7 is 3. Since 21 is divisible by 7, our original number, 357, is also divisible by 7. So we can confidently say that 357 is divisible by 7. Let's try a larger number. Is 659 divisible by 7? We'll test 659. The last digit is 9. Doubling it gives us 18. 9 doubled is 18. Now we subtract 18 from the remaining digits, 165. 165 minus 18 is 147. 147 is still a bit large to check in our heads, so we repeat the process. The last digit of 147 is 7. Doubling it gives 14. For 147, the last digit is 7. Doubling it gives 14. Subtracting 14 from the remaining digits, 14, gives us 0. 14 minus 14 is 0. A result of 0 means the number is divisible by 7. So 659 is divisible by 7. We have successfully applied the divisibility test for 7. Now let's explore a fascinating shortcut for division by 7 when the number is not perfectly divisible. You will discover the recurring decimal pattern for fractions with a denominator of 7. When you divide a number by 7 and it doesn't go in evenly, you get a decimal. For any fraction with a denominator of 7, this decimal will always be a repeating pattern of the same 6 digits. This pattern is 1, 4, 2, 8, 5, 7. It's a cycle of 6 digits that repeats forever. The amazing part is that every fraction with a denominator of 7 will use these exact same digits, just starting at a different point in the cycle. Let's see this in action. First, let's find the decimal for 1 divided by 7. 1 divided by 7 is 0.142857, and then the pattern repeats. Now, let's try 2 divided by 7. The decimal will be the same digits, but it will start at the R2 in the cycle. 2 divided by 7 is 0.285714, and the pattern repeats. Let's apply this to a larger number. What is 94 divided by 7? First, we do the long division to find the whole number part and the remainder. 94 divided by 7 is 13 with a remainder of 3. This means 94 over 7 is equal to 13 and 3/7. Now, we just need to find the decimal for 3 divided by 7. We look at our cycle, 142,857, and find the 3. Since there's no 3, we can think of it as 30 divided by 7, which is 4 with a remainder. So the decimal starts with 4. The decimal for 3/7 starts with 4. So 3 divided by 7 is 0.428571, repeating. Putting it all together, 94 divided by 7 is 13.428571, repeating. We found the decimal without doing any long division after the first step. So 94 divided by 7 is 13.428571, repeating. Let's try another one. 873 divided by 7. First, the long division. 873 divided by 7 is 124 with a remainder of 5. So we have 124 and 5/7. Now for 5/7, we look at our cycle, 142,857. The decimal for 5/7 will start with 7. The decimal for 5/7 starts with 7. So 5 divided by 7 is 0.714285, repeating. Combining them, 873 divided by 7 is 124.714285, repeating. There's our answer. One last example, 5,162 divided by 7. Long division gives us 737 with a remainder of 3, so we have 737 and 3/7. We already know that 3/7 is 0.428571, repeating. So 3/7 is 0.428571, repeating. Therefore, 5,162 divided by 7 is 737.428571, repeating. This shortcut is a powerful tool for quickly finding these decimal expansions. And that's our final answer. Next up is the number 11. In this scene, you will learn a simple and elegant divisibility test for 11. The test for 11 is based on the alternating sum of the digits. It's quite clever. Here's the rule. Start from the rightmost digit and alternate between adding and subtracting the digits. If the final result is 0, or a multiple of 11, then the original number is divisible by 11. Let's write that down. Alternate adding and subtracting digits from right to left. If the result is 0 or a multiple of 11, the number is divisible by 11. Let's try an example. Is 132 divisible by 11? We'll test 132. Starting from the right, we have 2. We subtract the next digit, 3. Then we add the next digit, 1. So we calculate 2 minus 3 plus 1. 2 minus 3 is -1. -1 plus 1 is 0. Since the result is 0, 132 is divisible by 11. The result is 0, which means 132 is divisible by 11. Let's try a larger number. Is 9,603 divisible by 11? We'll test 9,603. Starting from the right, we have 3. We subtract 0. We add 6. We subtract 9. The calculation is 3 minus 0 plus 6 minus 9. 3 minus 0 is 3. 3 plus 6 is 9. 9 minus 9 is 0. Again, the result is 0, so 9,603 is divisible by 11. The result is 0, so 9,603 is divisible by 11. Let's try one more. Is 245 divisible by 11? We'll test 245. Starting from the right, we have 5. We subtract 4. We add 2. The calculation is 5 minus 4 plus 2. 5 minus 4 is 1. 1 plus 2 is 3. The result is 3. Since 3 is not 0 or a multiple of 11, 245 is not divisible by 11. The result is 3, which is not 0 or a multiple of 11. Therefore, 245 is not divisible by 11. Just like with 7, there's a shortcut for division by 11 when the number isn't perfectly divisible. You will learn how to find the decimal expansion for fractions with a denominator of 11. When you divide a number by 11 and it doesn't go in evenly, you get a decimal. For any fraction with a denominator of 11, this decimal will always be a repeating pattern of 2 digits. The pattern is very simple. For any fraction n over 11, the decimal is 0.09 times n, repeating. Or you can think of it as 0.09, 0.18, 0.27, and so on. Let's write that down. The decimal for n over 11 is 0.09 times n, repeating. Let's see this in action. What is 1 divided by 11? 1 divided by 11 is 0.09, repeating. This is 0.09 times 1. What is 2 divided by 11? 2 divided by 11 is 0.18, repeating. This is 0.09 times 2. Let's apply this to a larger number. What is 71 divided by 11? First, we do the long division to find the whole number part and the remainder. 71 divided by 11 is 6 with a remainder of 5. This means 71 over 11 is equal to 6 and 5/11ths. Now we just need to find the decimal for 5/11ths. We multiply 0.09 by 5. 0.09 times 5 is 0.45. So 5/11ths is 0.45, repeating. Putting it all together, 71 divided by 11 is 6.45, repeating. We found the decimal without doing any long division after the first step. So 71 divided by 11 is 6.45, repeating. Let's try another one. 245 divided by 11. Long division gives us 22 with a remainder of 3, so we have 22 and 3/11ths. Now for 3/11ths. We multiply 0.09 by 3. 0.09 times 3 is 0.27. So 3/11ths is 0.27, repeating. Combining them, 245 divided by 11 is 22.27, repeating. There's our answer. One last example. 9,603 divided by 11. Long division gives us 873 with a remainder of 0. This means 9,603 is perfectly divisible by 11, as we found with the divisibility test. The decimal shortcut confirms this. 0/11ths is just 0. So the answer is exactly 873. This shows how the divisibility test and the decimal shortcut work together. Now for a brief, but fascinating, connection between the number 11 and a famous mathematical pattern. You will see how Pascal's triangle relates to the powers of 11. Let's look at Pascal's triangle. It starts with a 1 at the top. Each number below is the sum of the two numbers directly above it. The first row is 1. The second is 1, 1. The third is 1, 2, 1, and so on. Now let's look at the powers of 11. 11 to the power of 0 is 1. 11 to the power of 1 is 11. 11 squared is 121. 11 cubed is 1331. And 11 to the fourth is 14,641. Do you see the connection? The rows of Pascal's triangle are the digits of the powers of 11. The first row is 1. The second is 1, 1. The third is 1, 2, 1, and so on. This is a beautiful example of how different areas of mathematics are interconnected. It's a wonderful pattern to observe. Let's bring it all together with some real-world problems. You will now apply the divisibility tests and decimal shortcuts to solve two practical scenarios. These problems are the kind you might find in a homework assignment or a test. Let's see how our new tools can help. Problem 1. In a class, each row of desks seats 7 students. If the class has 67 students, how many rows will be needed? To solve this, we need to divide the total number of students, 67, by the number of students per row, 7. We need to calculate 67 divided by 7. Let's use our decimal shortcut. First, we find the whole number part and the remainder. 67 divided by 7 is 9 with a remainder of 4. So 67 over 7 is 9 and 4/7. Now we find the decimal for 4/7. We look at our cycle, 142,857. The decimal for 4/7 starts with 5. The decimal for 4/7 is 0.571428, repeating. So 67 divided by 7 is 9.571428, repeating. This means we need 9 full rows and part of a 10th row. The result is 9.57, repeating. Since you can't have a fraction of a row, we must round up to ensure every student has a seat. Therefore, 10 rows will be needed. The answer is 10 rows. Problem 2. A budget of $5,732 is to be equally allocated amongst 22 employees. How much will each employee receive? Here, we need to divide the total budget, $5,732, by the number of employees, 22. We need to calculate 5,732 divided by 22. Let's use our divisibility test for 11 first. Is 5,732 divisible by 11? 2 minus 3 plus 7 minus 5 equals 1. No, it's not. So we'll have a decimal. The test for 11 shows it's not divisible. Now let's do the long division to find the whole number part and the remainder. 5 732 divided by 22 is 260 with a remainder of 12. So we have 260 and 12 20-seconds. We can simplify the fraction 12 over 22 to 6 over 11. Now we can use our shortcut for 11. 12 over 22 simplifies to 6 over 11. The decimal for 6/11 is 0.09 times 6, which is 0.54, repeating. The decimal for 6/11 is 0.54, repeating. So, 732 divided by 22 is 260.54, repeating. In terms of money, this means each employee receives $260.54. The answer is $260.54. Let's quickly recap what we've learned today. We started by understanding what divisibility tests are and why they are useful shortcuts. We then learned the divisibility test for 7, double the last digit, and subtract it from the rest. We also discovered the 6-digit repeating decimal pattern for fractions with a denominator of 7. Next, we explored the divisibility test for 11, alternate adding and subtracting digits. We also found the 2-digit repeating decimal pattern for fractions with a denominator of 11. Finally, we saw the beautiful connection between Pascal's triangle and the powers of 11. You are now equipped with powerful tools to check divisibility and find decimal expansions more quickly and efficiently. Keep practicing these tests, and you'll build a stronger intuition for numbers. Thank you for watching.